Good morning, I am Devasena. In this lecture, we are going to discuss about network topology. This topic is present in the subject circuit analysis or circuit theory. Basically, network analysis is nothing but finding unknown branch currents or voltages across various branches. We can find these unknown parameters by using different network simplification techniques. These network simplifications involve basic Kirchhoff's laws applications, loop analysis, nodal analysis, star to delta transformations, source shifting and source transformation. The mesh analysis and the nodal analysis are the most useful techniques for the analysis of a network. But the disadvantage in these networks is that the selection of unknown variables is difficult. The number of unknown variables increases as the network becomes complicated. Hence, in such cases, the network analysis is made really simpler by using concepts of the network topology. In a network topology, only geometrical structure of a network is considered. Basically, any network is the interconnection of various network elements which are either active or passive. Thus, in the network topology, only geometrical pattern is considered and different network elements are not considered. A linear graph is defined as a collection of various nodes and branches. A node is defined as a common point at which two or more branches meet together. A branch is a line joining two nodes which represents a circuit element. A graph of any network can be drawn by placing all the nodes which are points of intersection of two or more branches. The network elements are represented by the lines joining nodes. The voltage sources and the current sources are to be replaced by their respective internal impedances. If internal impedances are not known, replace the above mentioned sources by their ideal internal impedances. The ideal impedance of a voltage source is 0. So, replace the voltage sources in the network by a short circuit in the graph. The ideal impedance of a current source is infinity. So, replace the current sources in the network by open source in a graph. The nodes and branches are numbered. Let's start discussing about oriented graph and unoriented graph. Oriented graph is a graph in which the orientation of the branches are known in the given network and the same are transferred on the graph. The oriented graph is also called directed graph. When the directions of the current are not given in the network and the graph is without such orientations, such a graph is called unoriented graph. The representation of the oriented graph is given below. Now we start discussing about planar graph and non-planar graph. A planar graph is a graph drawn on a two-dimensional plane so that no two branches intersect at a point which is not a node. This is the representation of the planar graphs. A non-planar graph is a graph drawn on a two-dimensional plane such that two or more branches intersect at a point other than node on a graph. The non-planar representation is here. Now we start discussing about subgraph. A subgraph is a subset of branches and the nodes of a graph. There are two types of subgraph. They are proper subgraph and improper subgraph. Proper subgraph. If the subgraph contains branches and nodes less in number than those on the graph, then such a subgraph is called a proper subgraph. The representation of the proper subgraph is given. The first diagram represents the graph. In that, we are having 4 nodes as A, B, C and D. Apart from that, we are having 5 branches. The branches are numbered as 1, 2, 3, 4 and 5. Then the remaining diagrams we are having as a proper subgraph diagrams. In this proper subgraphs, when compared to the original graph, the number of branches and nodes are less in the proper subgraph. It is indicated in this diagram. Improper subgraph. If a subgraph contains all the nodes of a graph and the branches, a subgraph is called improper subgraph. The improper subgraph is represented here. In this graph, we are having 4 nodes A, B, C and D. Its improper subgraph is also having all the 4 nodes A, B, C and D. It is indicated in the diagram. Path. A path is an improper subgraph such that at the terminating node only one branch is incident. At the remaining nodes, 2 branches are incident. If a path exists between any pair of nodes, then graph is called a connected graph. Otherwise, it is called disconnected graph. Rank of a graph. If there exists a number of nodes or the vertices, then the rank capital R of a graph is given by the relation capital R is equal to n minus 1. Tree. Tree is a set of branches with every node connected to every other node such that any one of the branches removed changes this property. In other words, we can state that it is a connected subgraph of a connected graph containing all the nodes of the graph not forming any loop. Thus, tree is a set of branches with all nodes not forming any loop or closed path. Properties of a tree. Tree contains all the nodes on the graph. The tree does not contain any closed path. In a tree, there exists only one path between any pair of nodes. In a tree, minimum n nodes or terminal nodes are 2. Every connected graph has at least one tree. The rank of the tree is same as the rank of a graph, that is n minus 1. Tree contains n minus 1 branches if n are the nodes of the tree. Branch of a tree, that is twig and cotree. Now we discuss about branch of a tree, that is twig. A branch of a tree is called twig if there are n number of nodes on a graph, then the tree of a graph contains n minus 1 twigs. Cotree. A set of branches forming a complement of a tree is called cotree. The number of branches of a cotree equals b minus n minus 1, where b is number of branches of a graph. The graph and trees are represented here. In this, figure A represents the graph and figure B represents the trees. It is indicated in this diagram. Let us discuss about loop. In general, a network consists of n nodes which are interconnected in some way by B branches. Then it is possible to traverse adjacent branches starting at any node and returning to the original starting node in different ways. Such a closed path formed by the network branches is called as loop. Loop is a connected subgraph of a connected graph such that at each node there are two branches incident. If the two terminals are made to coincide, it will generate a loop or a circuit. The representation of loops are shown here. Properties of loops. A loop of a graph has following properties. There are exactly two paths between any pair of nodes in the circuit. There exist at least two branches in loop. The maximum possible branches in a loop are equal to number of nodes.